Hey guys, what's up? Today I'm going to share a little bit about my thought process as a teacher. So when I was creating a calculus exam a couple of years ago, I decided to not reinvent the wheel necessarily, just kind of look at other resources, other schools, and see what they do. And so I immediately Googled Harvard vector calc exam, not knowing what I would find. And so I found the Harvard page where they teach calculus 3, and I was looking for vector line integrals actually, and I found some practice exams. And when I was looking at those practice exams, I just happened to click on one, and I was thinking practice exam 2. And as I was looking through, I was looking for vector line integrals, and then I came across this problem right here. And this problem kind of freaked me out a little bit, but I think that's the whole point of the way that they make their exam problem, is to intimidate you a little bit. So I'll give you a little insight into me, but I'll also give you insight into their thought process, I think, as they create exams. And those are good resources, really, if you're going to practice, just to look up online exams. So the thought process I think that they have is to create the nastiest possible looking problem to intimidate you, to make you think, oh, I can't do this problem. When in reality, you should think to yourself, I can definitely do this problem. There's got to be some trick. And if we try to do this integral, it's actually not too bad. So if you see the part A of this problem, it says, find the work of the vector field over the curve. And they give us a vector field here. It looks pretty nasty. And they give us a curve. And what we can do is actually, well, I guess we could try to evaluate f of r of t dotted with r prime of t. So if we try to evaluate f of r of t dotted with r prime of t, it's going to get pretty nasty. So maybe we can try something else. So I go through all the work, I try to evaluate f of r of t dotted with r prime of t, and it doesn't really work out. And so I'm thinking to myself, maybe I'm missing something. Maybe I should try a different way to evaluate a line integral. So we have another way to evaluate a line integral if the field is conservative. So if the field is conservative, hopefully, maybe you already saw this. If the field's conservative, we can use the fundamental theorem for line integrals. So if I use the fundamental theorem of line integrals, I just need to find the little potential function, little f, such that the gradient of little f is equal to the field that they gave me already. So that's what I try next, and I think, oh yeah, this field kind of feels like it could be conservative if I integrate the first component with respect to x, and the second component with respect to y, and the third component with respect to z. So, and I find the overlapping part, and that must be f, and then the independent parts, those must be part of f too. So I find a potential function that actually gives me a gradient of little f equals capital F. And so that tells me the field is conservative as long as those partials are continuous or whatever those conditions are. So I have to double check those, of course, before I use it. But then all I need to do, if I have the potential function, is to evaluate f of r of b minus f of r of a, where f, little f, is what I'm talking about. So if I can do the fundamental theorem for line integrals, then I can actually solve this problem very easily. So we'll see that it actually does work out, and we get a pretty nice, neat, I would say, looking answer. And so this line integral, although it seems super intimidating from the beginning, is actually no big deal. You guys probably saw it before I did. So I would, just like any normal teacher, I decided to immediately put this problem on my test. Of course, why not? This is an amazing problem. So I did. I put this problem on the test, and I'll show you exactly which test it was. It was for us, a fall quarter. And I put it on the test. It was actually a bonus question because, it's a little intimidating. So it's a little tricky if you've never practiced with these types of problems before, but I did put it on my test, and I had a bunch of people try it as the bonus problem, and probably out of the class, like maybe half the people tried it, and out of those, half the people got it right. So I could say a quarter of the class, first time they ever see a problem that's like engineered to be super tricky did pretty well on that problem. So typically, if you see a problem that's super hard, specifically a line integral, if you see a line integral that looks like f of r of t is just getting like out of control, then you might just like try something else, like try to use the fundamental theorem for line integrals or Stokes theorem or something like that. Like that's usually a tip or an indicator that you need to try something more powerful or something more than just the definition. So hopefully you found this really helpful. Hopefully you found it interesting. Thanks for watching. Don't forget to subscribe if you like this video. If you want to check out some of my other videos, please do. I have tons of like example problems. That's why I started this whole channel in the first place. So thanks for watching. See you next time.